All right, so for this test, the first page is all just warm-up stuff. I just wanted to remind you, you want to know things like the product rule, the quotient rule, and the chain rule. You want to know them very quick, you want to know them very easily, and you want to know how to do them when they're composited. So if you have like a quotient within a chain within a product rule, right? How would you handle that? And the trick to those is you want to do each one at a time. Now for the warm-up derivatives, these are all the derivatives you should know cold. So I'm going to let you try to fill those in. The thing that you want to do for these is make sure that you know how to just know how to do them, and also what happens if you forget one of them on the test. For example, do you know how to where it comes from? Do you know uh, how to come up with the solutions very quickly? And then I'll actually work out the next problems in detail. Okay, so questions 1 and 2 you just have to fill out. So let's actually do some derivatives here. So for the first one, we're going to have the derivative of x to the 101, which is equal to the 101x to the 101 minus 1. So the answer for 3a is 101x to the power of 100. For part B, what we see is, this is of course an application of the chain rule. So let me rewrite this so you can see this in colors. That's just going to be 3, and the exponent is 3x. So when I take the derivative of 3 to the 3x, 3 times x I should say, the derivative of the outside is going to be 3 to the whatever times the natural log of 3. But on the inside, I'm going to put 3x, and don't forget by the chain rule I have to take the derivative of that inside, which is 3. And that's our answer. Now I should also put a little note here that for the test, you should definitely know the difference between 3 to the x to the third, 3 to the third, that's just a constant, that derivative is 0, and x to the x. Each one of these is wildly different, and as a result, needed a totally different derivative. But let's move on to C. We're going to use the product rule. So we have the derivative of this, we're going to have sine of x squared times cosine of x squared. So we have a product rule, we have the first and the second. So we're going to have, the first one is, we're going to have the first times the derivative of the second plus the second times the derivative of the first. And this needs a chain rule. Don't forget here, this is going to use a little chain rule here. So it has an inside. So I'm going to have sine of x squared times, the derivative of the outside is sine, and the inside is x squared, and the derivative of the inside is 2x. So again, that's by the chain rule. Then we're going to have plus cosine of x squared times the derivative of sine is going to give us negative cosine. And on the inside we have x squared, and then we have the derivative of the inside is 2x. Now you'll notice I can factor out a 2x from both sides. So I really just have 2x sine squared x squared, because I have two of those little guys there, minus, and then I have two cosines here, that's going to be cosine squared x squared here. All right. Now for the D, the thing that you have to know before we begin is that we have to know that the derivative of the inverse of cosine is -1 divided by the square root of 1 minus x squared. Now again, either you can have that memorized or you can derive it real quick. It's whichever one's easiest for you. I'd encourage you to memorize it, but try to know where it comes from just in case. And this is going to use the quotient rule. Okay. So I'm going to have the bottom times the derivative of the top minus the top times the derivative of the bottom, which is negative sine of x, all divided by the bottom squared. And you can simplify that if you want, but I'm going to move on. Alright, so for this next one, again, it's a product rule. So I have two terms. So the derivative dx of 2 to the x tangent of 2x. Alright, so I have the first times the derivative of the second. I'll just write that. Plus the second, tangent of 2x, times the derivative of the first. And the first is going to be 2 to the x times the natural log of 2. So really we just have to simplify this guy and we're done. So that's going to be 2 to the x. And the derivative of tangent, remember, is going to be secant squared. So that's just going to be secant squared. The inside is 2 to the x, and then I have to take the derivative of the inside because of the chain rule. So 2 to the x times the natural log of 2. And then all these other terms just kind of follow along. You can factor out a natural log of 2 and a 2 to the x if you want, but I'm just going to leave it there since it's asking for just the derivative. Okay. Now for f, now here's the thing about f. You have the chain rule multiple times, but let me show you how this works. Because you're really just applying one rule at a time. Let me make this a different color so we can see it. This is going to be e to the sine of cosine of x. So when I take its derivative, first thing I'm going to do is take the derivative of the outside, which is e sine, and then I'm going to put inside cosine of x, and then I have to multiply by the derivative of the inside, which is sine cosine of x. Alright, so I get e to the sine of cosine of x, alright, whoops, times, and the next one is I got to use the chain rule yet again, so I got to use chain again. So that's going to be the first one, the derivative of cosine is, or sorry, I gave the answer. The derivative of sine is cosine. And on the inside I have cosine of x. And then I have to take the derivative of the inside one more time, and I get negative sine of x. So my answer for this is negative e to the sine of cosine of x times cosine of x times sine of x. Alright, now be very careful. Like I said, you only do one step at a time. So here I just did one chain rule and then I did one chain rule again. When people see these types of things, they try to do all the chain rule problems all at once or try to do multiple problems at once, but it's actually just easier if you just do one rule at a time. Alright, this next one says, suppose we have a position particle that's given by s of t is equal to t cubed minus 9t. So the question is, when does it have height 0? So when does it have height 0? That's the same thing as just asking s of t, when is s of t equal to 0? Now the thing that you want to note here is t has to be greater than or equal to 0. You can't go backwards in time and unless you have a flux capacitor, which we don't really have, so we'll take that off. So we have S of t is equal to 0 precisely when we have t cubed minus 9t is equal to 0. So we have 9, I can factor 9 out of that, get 9 squared minus t squared minus 9 is equal to 0. So we get t times t minus 3, t plus 3. It's a difference of 2 squares. You can factor that easily. So we end up having t is equal to 0, t is equal to 3, or t is equal to negative 3. But we can't have negative 3 because of our restriction here. So the answer is only t is equal to 0 and t is equal to 3. That's the only answers that we have. So be very careful on multiple choice tests when you have that. The next one says, what's the velocity? So again, the velocity, that's the same thing as just saying taking the derivative. And when you take the derivative at 2, that's the same thing as just saying, well, take the derivative. Whoops, take the derivative and put in 2. What's that going to be? All right, so the velocity is the derivative. So we have 3t squared minus 9. And the velocity at 2 is, again, the same thing as taking the derivative of position at 2. And you get 3 times 2 squared minus 9, which is equal to 3 times 4 minus 9, which is 12 minus 9, which is 3. We don't have any units here, but it'll be units of distance over time. Now for this next question, it says, at what t values does the graph of the position have horizontal tangent lines? So if we take a look at that, we know that that's going to occur, and again we're talking about position here. When does the position have that? That is when the derivative is equal to 0. Or another way of saying that is, when is the velocity equal to 0? So remember, the velocity function, v of t, we've already did that in the previous problem, is going to be 3t squared minus 9. And I'm going to set this equal to 0 to solve. Okay, so I can, if I take 3t squared minus 9 is equal to 0, I can divide everything through by 3, and I get t squared minus 3 is equal to 0. Now I'm going to get t is either equal to plus or minus the square root of 3, but remember, t is equal to negative square root of 3 is not a viable answer. Remember, we need t to be greater than or equal to 0. So t is equal to the square root of 3 is our only answer. Now, the next question says, what is the total distance? Total distance traveled. So we know that here we have a particle, I'll just start it here. This will be at t is equal to 0. And I know that it's going to go some direction back until we hit t is equal to the square root of 3. And then after that, it's going to go forward. Okay, so we want to be able to count this twice, and we want to count it up to t is equal to 4. Now you may ask, how did I know it goes backwards at first? Well, if you look at the velocity function, this is a very simple 3 t squared minus 9. This is a simple parabola, and this is what the velocity looks like, right? You have square root of 3, negative square root of 3. So we know that the graph is actually, and again this is the velocity, so we know that the position is moving backwards from 0 to square root of 3 and then forward from square root of 3 to 4. So the way I'm going to do this is that the total distance traveled is going to be s of, first distance I'm going to do is square root of 3 minus s of 0, and then I'm going to go s of 4 minus s of square root of 3. Now remember, I got to put this back in the original function, and the original function is going to be equal to t cubed minus 9t. Alright, so that's going to be equal to the square root of 3 cubed, alright, minus 9 times the square root of 3. That's the first one. I'll put parentheses here. That's this first guy. Minus, and if I put 0 in there, I get that. Plus, okay, if I put 4 in there, I'm going to get 4 cubed, all right, which is 4 times 4 times 4, so that's 16 times 4, which should be 64. I knew that one wasn't too bad. Minus 4 times 9, which is 36. Minus all the stuff that I got here. So minus what I had in the parentheses, which is going to be this square root of 9 cubed minus 9 square root of 3. Alright, so let's clean this up. Alright, so what do we get here? Square root of 3 cubed, that's just equal to 3 square root of 3 minus 9 square root of 3, absolute values. And that plus 64 minus 36 should be 28 minus, and then the part in blue, we already know that that's just going to be 3 square root of 3 minus 9 square root of 3. Okay, so we end up getting, the first one is going to be equal to 6 square root of 3. All right. Then we're going to get plus 28. You can think of this as 9 minus 3. That's going to be plus 6 square root of 3. And then that whole thing just simplifies down to 12 square root of 3 plus 28. So you want to be a little bit careful with your numbers there. Okay, next question. It says, suppose that we have that f of x is equal to the inverse arctan, or just arctan, of 4 over x of cubed. Okay, so the first thing we got to do, we want to find the tangent line at 1/4. Okay, so first of all, at 1/4. Okay, so the first thing I need to do is find the slope. So the derivative of this thing, don't forget it's going to be a chain rule. So I have the derivative of the outside squared, and I'm going to put on the inside 4x. And again, like I said before, you're only doing one rule at a time. Don't try to do too many rules at once. You'll probably mess up. Okay, so the next one is 3, and then this is again squared, and we have arctan, I didn't change that, of 4x, times, now the derivative of the inside, that's this piece here. This is going to be using a chain rule again, so we have to use the chain again. So we have the chain. And the derivative of the outside of this one is going to be 1 over 1 plus something squared. And again, I got to use the chain rule, so it's going to be 4x. And the derivative of the inside is just 4. Okay. So the slope is going to happen at x is equal to 1. X is equal to 1/4. Okay, so let's see what happens when I put all this in there. So I'm going to have 3 times the arctangent of 4 times, was it 1? Yeah, 1/4. 1/4 squared times 1 over 1 plus 4 squared times 4. Okay, so I get 3. And the arctangent of 1, remember, is just pi over 4. Okay, times, now I have 1 over 1 plus 1, which is 2 times 4. So basically, that gets turned into, let's see, what do I have here? I'm going to have 12, let's see, let me just write it all out. 3 pi squared times 4 over 4 times 4 times 2. So the 4's cancel. Sometimes it's better, you can actually see how I do these things. It's actually sometimes better not to multiply it all out and then divide. Sometimes it's just easier to write it all out and then divide. So that's just going to be 3 pi squared over 8. So that's our slope for that little guy. All right, now the point that we have x is equal to 1/4. And so that means that our y is going to be f of 1/4, which is going to be the arctangent of 4 times 1/4 cubed. But we already know the arctangent of 1 is pi halves. So it's going to be pi halves cubed. So that's pi over 8, pi cubed over 8. Cubed. So now we have the equation of a line. So now we have a point and a slope. So we have y minus y sub 1 is equal to m times x minus x sub 1. So we have y minus pi cubed over 8 is equal to 3 pi squared over 8 times x minus 1/4. And I'm not really going to simplify this, I'm just going to leave it as writing it this way so we can see it. Y is equal to 3 pi squared over 8 x minus 1/4 plus pi cubed over 8. I'll leave it like that. You can clean it up a little bit, just depends on your answers, but that's an equation of a line, so I'll go ahead and use that. Alright, for the next one, I want to calculate this guy, so let's do that. I have h of x is equal to f of x times g of x plus 2x. So its derivative, I have to use the product rule first. So I'm going to have the first times the derivative of the second plus the second times the derivative of the first plus the derivative of the last guy is just 2. And if I plug in 1 into all this mess, I get f of 1 times g prime of 1 plus g of 1 times f prime of 1 plus 2. And we can figure out what this is relatively quickly. So we know that f of 1 is 1, so everywhere I see that, that's equal to 1. Okay. I also know that the derivative of f, that's equal to 2. I can see that g of 1 is 3. And lastly, g prime of 1 is negative 4. So the derivative of this is going to be equal to 1 times negative 4 plus 3 times 2. I almost put the answer down. I got way ahead of myself on that one. So that's going to be negative 4 plus 6 plus 2, which is just going to be equal to positive 4. Alright, so for the next one, it says, consider this curve x squared plus xy plus y squared is equal to 4. At what points does it have horizontal tangent lines? And what are the equations of the tangent lines? Now before I do that, I need to figure out what this derivative is. So I have dy over dx. So when you see the word horizontal tangent line, you're looking for when does dy over dx equal to 0. The next question is, when is the vertical tangent line? That's when the function is continuous, but you have dy over dx does not exist. Does not exist, but does exist, but it does exist on the function. But the points exist. Exist on the curve. So you're looking for points on the curve where the derivative doesn't exist. All right, and remember, that may sound counterintuitive. You're like, well, how can that happen? But imagine if I have a circle, for example. You know, here's just a quick example. If I have a circle here, the point exists, but I have a vertical tangent line at that point and that point. So those are my vertical tangent line. Okay, but before I do any of this stuff, I have to figure out what this derivative is, the dy over dx. So I start here. I have x squared plus xy plus y squared is equal to 4. I take the derivative. The first one is I'm going to have 2x, and the derivative of the inside, using the chain rule, dx over dx. The second one is this product rule. So I have the first times the derivative of the second plus the second times the derivative of the first plus 2y times the derivative of the inside is equal to 0. Now, a couple of things. I put in all the dx's so you can see it, but some students are pretty good at it. They don't need that. That's perfectly fine. I like to put it in there as placeholders just in case I get lost, because technically every term should have one, should have something. Every time you do implicit differentiation, each one should have something as a rule of thumb. It just so happens it turns out some of them are going to be 0. So for this, I have 2x plus x times dy over dx plus y plus 2y times dy over dx equals to 0. And I'll factor these little guys out, these two little guys out of there. So I'll have, and then everything else I'm going to put on the other side. So I'm going to bring this to the other side. I'm going to put this on the other side. So I have x plus 2y times this dy over dx is equal to, and I'm going to put all the other stuff to the right hand side. I did two things in one step. Hopefully you can follow me on that. But basically all I did was I just put all the dy dx's on one side and everything else on the other. So now my dy dx is going to be equal to negative 2x minus y divided by x plus 2y. Okay, and I'm going to use this equation for both a and b. All right. Now for part A, for the horizontal tangent line, you need the numerator. So in this case, the numerator is going to be equal to 0. So we're going to solve when is dy over dx equal to 0, and that's the same thing as when is the numerator equal to 0, and you get negative 2x minus y is equal to 0. So then you end up getting just y is equal to negative 2x. Now what I'm going to do is I'm going to put this equation back into the original. Okay. So everywhere I see a y, I put in 2x. So I have x squared plus x times 2x plus y squared is equal to 4. Oh, but this y, just almost forgot this little y. This little y, that's also negative 2x squared. All right. So now we're going to get, on the left-hand side, we're going to get x squared minus 2x squared plus 4x squared equals 4. That's going to give us 3x squared equals 4. So now we have two different answers for this. We're going to get, we have x squared is equal to 4/3. So let me come back over here. So we have x is equal to either plus the square root of 4/3, which is just, again, plus 2 over the square root of 3, or we have x is equal to negative square root of 4 over 3, which is negative 2 over the square root of 3. Okay. Now to find the y values, the corresponding y values, remember the y. Remember, y is equal to negative 2x. I just multiply it by 2. So the corresponding y is equal to, in this case, just multiply that by negative 2 times 2 over the square root of 3, which is negative 4 square root of 3. And the same thing goes for this one. I just multiply it by negative 2. So now I'm going to have 4 over the square root of 3. So our points for this, horizontal lines, is just going to be, my x value is 2 square root of 3, comma my y, negative 4 square root of 3. And I'm going to have negative 2 square root of 3, comma the positive 4 over square root of 3. So there are 2 points. Now the equation of the line, the equations are actually really easy. Let's see what I asked you. What's the equations of the horizontal tangent lines? Well, the equations is just y is equal to negative 4 over square root of 3, and y is equal to 4 over square root of 3. As a hint, it's just a straight line. Recall, the slopes are 0. All right. So, again, if you write the equation of a line, you have y minus y1. Let me show you real quick. If the slope is 0, y minus y1 is m times x minus x1. If that's equal to 0, then you just have y minus y1 is equal to 0, so then you just have y is equal to y1. That's how I knew that when I looked at this, I just needed the y values, because the slopes are going to be 0. Or the slopes are 0, so I don't have any to worry about the equation of a line. The equation of a line is really simple. It's just constant if the slope is 0. Okay. Now, for the next one, again, I start off with the same equation. I've already did all the work. I don't have to redo it. You don't want to waste your time on the test redoing calculations if you've already done them. Now in this case, I'm going to look at the bottom, the denominator. Okay, so for the vertical tangent line, I need the bottom to be equal to 0 so that the slope doesn't exist. Okay, I need the x plus 2y is equal to 0. So I need x equal to negative 2y. It's almost the exact opposite, or the quote, I mean, not quite the exact opposite, but you get the idea. Okay. Now for this, I'm going to put this back in the original formula. So remember what our formula is. Our formula is we have x squared plus xy plus y squared is equal to 4. And what I'm going to do is I'm just going to put in everywhere I see an x, I'm going to put in negative 2y. So I get in negative 2y squared plus negative 2y times y plus y squared is equal to 4. So I get 4y squared minus 2y squared plus y squared is equal to 4. All right, on this side, I'm going to get I get 3y squared equal to 4. So now y is equal to, or y squared, I should say, is 4 over 3, which means that y is equal to either positive 4/3 or the negative 1. And of course, that just simplifies down to 2 over the square root of 3, And this simplifies down to negative 2 over the square root of 3. Okay. So the question is, well, what is x? And again, just like before, we know what our x is. Remember, down here, x is equal to just negative 2y. So if I multiply this out, I get x is equal to negative 2 times 2 over square root of 3, which is negative 4 over square root of 3. And here I just multiply this by negative 2 as well. Negative 2 times negative 2 over square root of 3, which gives me positive 4 over square root of 3. Now the slope here is undefined, but let's write down our points. So for our points, we have our x. Now don't forget, some people mess this up. It's easy to do this, but remember, in this one, we did our y's first. So we have to write down our x's first to get the right answer. That's an easy one to mess up on a multiple choice part. But we have negative 4 over square root of 3, comma 2 over square root of 3 as our first point, and our second point is going to be the same idea, 4 over square root of 3, comma negative 2 over square root of 3. All right. Now with the vertical tangent line, the equation of the vertical tangent line, it's the same thing. So remember, with horizontal lines, you get the equation of y is equal to a constant. Whoops. Constant. I messed up that spelling. Constant. And for a vertical line, you just have x is equal to a constant. So in this case, the equation of our line is just going to be x is equal to negative 4 over square root of 3, and x is equal to 4 over square root of 3. Okay. And that does it for this problem. Now, as a word of caution, this review is not complete. So make sure that you know how to do things like related rates. Make sure that you know how to graph, how to read tables, etc., etc. So again, you want to look at the old exams to give you ideas of what this test is going to cover. This review was just rather quick. Just picked some random problems for you to work on. So hopefully that makes sense, and wish everyone luck on the test. So good luck.